Okay, then let's start. Hello, everyone. Welcome to my talk about MQTT, the protocol for the Internet of Things. My name is Jens Deters. I'm working at CodeCentric in Germany, near Munich, actually. And I'm working there as a senior IT consultant. So we do projects at in the financial sector, in the insurance sector, also automotive sector. So that's our main customers. And I would like to talk about MQTT. Has anybody heard about MQTT? Oh, quite a lot. Are you using MQTT at home or in projects or? Okay. Good. Are you involved in any IoT projects? Any IoT-related projects? Which kind of industry? Or not only at home, for really professional projects in the industry or insurance? Okay. Which? Ah, okay. Ah, interesting. Uh-huh. Okay. So it's not in production rate yet. Okay, you're working on it. You also involved in IoT project? Okay. And do you use MQTT as a transport protocol for that? Or? Ah, okay. Okay. Yeah, I'm currently involved in a project for a German or for German car manufacturers. They are working on transporting real-time data from cars to a fast data pipeline for doing some data mining and analyzing, checking out events. And for this kind of transportation, we really actually are using MQTT. So the data from the cars to the first the first broker on the other side, it's MQTT. So some insights about my career so far. 25 years ago, or almost 25 years ago, so I'm mid-40s. It's quite a long time. I used to have these little home computer from Commodore. It was the Plus 4. It aims to be the successor of the very successful C64, but I've heard that the designers or the product managers of these Plus 4, C16, C116, they stated that the only thing that they did right with these computers were the color, so they were right colored for their own funeral. Because they basically had no hardware sprites, so they were more or less unusual or useless for gaming, and I think that's a key factor for a success for such kind of a product. But this one had a user port. It was quite similar to the C64 user port. You were able to per peek and poke to read and write 8-bit data to this port. And I also created this kind of interface, switch interface with 8-channel switch interface to control 8 lamps in my party room at home. Later I really found out it was really quite dangerous because there were 230 volts coming in here and switched by 5 volts from here, and it was a direct connection to the user port of my computer. So lucky me, it went very well, so I never had an accident, and the machine survived. So this one is still in operation, or it can be turned on. Then a few years ago, the Internet of Things popped up with several small devices, so like credit card-sized computers for like the very famous Raspberry Pi, but also Arduino, and some other boards from BeagleBone and QB-board, and some more professional boards from Intel, and a very interesting microcontroller, which is called ESP8266. It's a very small microcontroller, but the really good thing about this small device is it has a full Wi-Fi stack on board, so really small chip with full Wi-Fi access, and it is also Arduino compatible. So you can use all the existing drivers and software which is available for Arduino, more or less, also for this small device. That's what I'm actually also using in my demo network, which I will introduce soon. But if you're starting with IoT stuff and you have an Arduino and a sensor, basically for instance a temperature sensor, you are very happy to get the current temperature printed out to a console or a serial interface. But at a certain point you will ask yourself how to transport the data from the sensor to something like this UI to display the sensor values or to control some actor devices. And yeah, this leads to IoT protocols. And one of these IoT protocols, which are more or less, I think, industry standards and very much accepted by the industry, is MQTT. MQTT was invented by IBM in the late 90s to mainly focus to control oil pipelines. So it was designed for very small devices with very low bandwidth. And the upcoming Internet of Things also with small devices, let the MQTT protocol be very attractive again. MQTT is for MQ telemetry transport. It's not message queue. It's a kind of message queue, but it's not really a message queue. MQ was a product series of IBM started that day, so that's why it is called MQ mainly. MQTT is a publish-subscribe protocol. So what you need for this kind of pattern is a broker in the middle. It's a server, and the messages are transported and exchanged via topics, so-called topics. So there's a subscriber who tells the broker, I'm interested in messages sent to this certain topic. The subscriber is subscribed and known by the broker, and if there is a publisher publishing any data to this topic, all subscribers will be informed by receiving that message which was published before. And after that, the broker will delete the message. Once it's delivered, basically, the broker will not store. There is a way to store the message or the last message which was received for this certain topic, but basically this message is deleted. That's why it's not really a kind of a message queue, because if a message is published and there is someone who was subscribed for this topic, he will receive the message, but if there is no subscriber for this certain topic, the message will be deleted. Except for a certain quality of service levels or for so-called retained marked messages. This is topics can be defined in a kind of a hierarchical structure, like a directory structure on your file system of your OS. There's a topic level, just an ASCII-based name. Could also contain some special characters and also numbers. And there's a topic separator to separate the topic level from each other topic levels. It's mostly not starting with a topic separator because it really makes no sense to start with a slash. It's just a topic separator. So the best practice is not to start with a topic separator. And additionally to the topics or the topic levels, you can use wildcards in your topics. So there's a single level wildcard, it's a plus, or a hash, it's a multiple level. What's the difference? This is a single level. This means at this position you can have any kind of topic level printed, but just one. So it's just one level between these slashes, between the topic separators. So one is subscribed to this topic, will receive messages, for instance, sent to bathroom humidity or also living room humidity. So it doesn't matter what's between these topic separators, right? For instance, in our current project we use this kind of wildcard to also code or include a kind of a session indicator in the topic structure. So there's a variable part. It's the session ID, which is included in the topic name or in the topic structure. And clients who are subscribed at this kind of single level wildcard topic will receive all messages to this base structure, no matter what the current session ID is or is coded in this kind of topic. And there's a multiple level wildcard, this hash. This means I don't care what's coming next. I will accept, or I want to receive any messages based on this topic. So starting with this topic, and it doesn't matter what's coming afterwards. That's it with the wildcard topics. There are also quality of service level. Mostly used in mass data setups is for sure QoS 0. So it's a kind of fire and forget and no guarantee quality of service level. If there's a receiver for this message, I'm fine. If there's no receiver, just delete it. So messages might be dropped or might not be received. There's no guarantee that this message is really delivered. There's a more guaranteed way with quality of service 1. So at least once, this message must be delivered at least once. So one subscriber must deliver, or must receive this message, at least one, maybe more. And there's quality of service 2. It's exactly once. So this message must be received by exactly one subscriber. Well, this is costs a lot of bandwidth. There's some handshake signals between publisher, broker, subscriber, or mostly broker and subscriber. And in most of the setups, you won't need quality of service 1 or 2. So in our projects, we're using quality of service 0 because it's such a huge load of messages. If some messages are not received, it's okay for us at the end of the day. There's also a kind of security level in MQTT. There's a little user management. You can use username and password for the clients to be, for the client connection to be accepted. There's also a way to restrict access for publishing or receiving, publishing and subscribing for certain topics with access control lists in the setup of the broker. But this depends really on the broker, which kind of access control lists are accepted or how it is defined. But basically, you can secure all client connections with TLS and SSL. MQTT is a TCP-based protocol, so you can clearly use also TLS for securing the transport layer. And there's another way to encrypt also the payload. So MQTT message has a very little header, 2 or 4 bytes. It depends on the length of the payload, and the rest is really binary payload. I think there's a limit. It's 260 megabyte per message, which you're able to transport as a payload per message. And if you need more security than username password in the transport layer, you can also encrypt the payload. But this, on the other hand, this also really depends on what your publisher is able to create. So with a small device or a small microcontroller, maybe you won't be able to encrypt the payload in a certain way. There's another flag which can be messages can be marked with. It's a retain message. Messages sent with this retain flag will be stored at the broker as the last known good message. This is quite interesting if you have sensor devices transporting, for instance, I don't know, temperature, and you want to make sure that any new client which connects to the broker receives the last known message which was sent to this topic instantly, immediately, while it's connected. So if you have sensors around your house or your location, and you're sending retained messages, or you're sending messages, I don't know, in an interval of 15 minutes, and a client is connecting, maybe he has to wait for 15 minutes to receive the next message. But if the last message, or if the messages are marked retained, the client which is connecting will immediately receive the last message which was sent to that topic. Okay, understand? Okay. There's another option. It's called last will and testament. It's a bit pathetic, but it has to do with a dying client or a connection lost to the client. The client who is connecting to a broker is able to can define a last will and testament. So what should be sent out when I am losing the connection. So if a client is losing a connection, a message is sent, well, that client did lost connection. There's another thing, there's a special topic. There's a topic structure with start with these $sys, so dollar symbol and sys letter. So it's not a common standard, but there's a kind of common definition of these sys topic structure. Via subscription to these sys topics, you are able to receive some status info of the broker. Is the broker alive? Okay, he might be alive if you're able to connect, but you can just also receive The broker version, the supported protocol version, how many messages have been sent and received, how many clients are connected, so some status info, meta status info of the broker connection or the broker status itself. So in a nutshell, MQTT is for MQ telemetry transport. It's based on an observer pattern with subscribers and publishers and a broker in the middle. It's TCP based. It's an asynchronous protocol. You have quality of service, last will and testament messages. There's a security layer. Topic wildcard patterns are supported. And there's another thing which I'm using at home and in my demo network I will introduce soon. There's broker bridging support. So you are able, a broker, MQTT broker, is able to be also a client for all or certain topics of another broker. Just to transport all messages published to a certain topic of broker 1 instantly to broker 2. What is it good for? So in our current project there's a kind of an legacy pipeline using an MQTT broker, and in parallel we are setting up a new data pipeline with another separate MQTT broker. And during this setup phase, we are bridging all topics, so all messages which are sent to the legacy broker, also to our new broker. And once the legacy pipeline can be switched off, we are just subscribing or just have to connect the clients to the other broker, to our new broker. But meanwhile, we can set up our new pipeline as a charm. So this really runs very smoothly. That's one use case for this broker support. So basically, MQTT, the MQTT usage of the MQTT protocol itself is really simple. So from an API perspective, you just have a kind of connect. You have publish, subscribe, unsubscribe, disconnect. That's very easy for MQTT clients, no matter if you're a publisher or a subscriber. It's a plain byte array, the message payload, just byte array, and you are able to code everything in it. This could be a binary payload or plain text or JSON, whatever. Very flexible. And the good news is there's a lot of client implementation. For instance, what I'm using most, and we are using most in our project, is Eclipse POW implementation. It's part of the Eclipse IoT foundation. And as you see, you have many supported languages. You will find a client for almost any popular programming language. Well, the most complete support is indeed for Java client library, but you also have a very good JavaScript implementation, and there's also WebSocket support to, for instance, communication. Really cool stuff. What you can do with this on the client side in the browser, for instance. And there's also another very good client implementation from Adafruit. Do you know Adafruit? Adafruit Industries. They have some very nice IoT hardware, sensors, boards. Also ESP8266 breakout boards, which I'm using, for instance. And they created an MQTT implementation for Arduino. So you can just use this ready-for-use library for connecting your Arduino or Arduino compatible to your MQTT broker. So now to MQTT-FX. This is MQTT-FX. It's a MQTT client, a desktop client, which you can use for testing and debugging MQTT message flow. Has anyone used this before, MQTT-FX? Okay, then I will give you a short introduction. MQTT-FX basically supports kind of a connection profile. So what you basically need as an MQTT client, you need the broker address and the broker port you want to connect to, and a unique client ID. So the broker is able to identify you as a connector, or as a no matter what, if you're a publisher or a subscriber. This has to be unique because if you're connected with a very simple client ID, and there's a second client which tries to connect with the same client ID, you will be kicked out. So you have to really find or generate. You can easily generate unique client ID here. Some general stuff like the MQTT protocol you want to use, and some timeouts. So user credentials, so username and password for your client to connect. Also the SSL and TLS layer. So maybe you just want to use the CA signed server certificate, or a specific certificate file, or a key store, a Java key store. It's all supported. There's a way to pass a proxy. So if your broker is outside your local network, and there's a proxy to control the web data flow, you can use this this option for bypassing the HTTP proxy or HTTPS proxy. And last will then testament can be defined also here. And this connection profile, this setup, is stored by a unique profile name for just easy and comfortable choosing the connection you would like to use for your MQTT session. This connection profile connects to my Synology at home. So I'm having a Synology with an MQTT broker. It's a Mosquito broker. It's a very lightweight broker, which is included in most of the Linux distributions, and there are also clients available for macOS, for instance. And what I'm using here is this bridging. So in my local network, I have a Raspberry Pi running this Mosquito broker. There's no security at all because it's my local wireless LAN, which is secured by VPA2, and I don't want to annoy to use my very lightweight hardware, sensor hardware, with all this username and password stuff. So there's no security inside. But for connection from the outside, from the internet, I have a second broker installed on my Synology, and there I'm also using the bridging support of MQTT brokers. So any topics from inside and outside are instantly, transparently bridged between these brokers. And the connection from outside to my Synology is secured by username and password, and also TLS secured. So now I'm connected with my broker at home. And what you can do to receive all messages which are currently published to a broker is to subscribe to the hash. So if this is a really this is a broker under load, you should not do this kind of subscription, because it may explode your client instantly. But I have just about 22 or 30 topics, so I think it's okay. And here on the right side, you're seeing the message flow. These are all messages who are received right now, and there's a decoding of the sent value. There's another tab for publishing values. You just have to enter a topic you want to publish to here, and define some payload in this text area, and then publish just this message to that certain topic. You're also able to define some quality of service level here, and to set the retained marker on that side. There's a scripting support. For scripted MQTT message flow, you are able, inside the Nashorn engine is used. Java 8 was introduced by Java 8, so JavaScript basically. So if I open up this, this little script, so it's really plain JavaScript. There's some special bindings to be used by the script. For instance, the MQTT manager. Via the MQTT manager, you have a direct connection to the current connection of the MQTT-FX client, and you're able to use this hook for instance, publishing messages. So what I'm basically doing here is just increasing and decreasing a value to a topic which contains so-called UV index values. So this is the value and the quality of service, and if a marker of the retained message. So if I want to be sent this message retained or not. I will use this script in the following demo then, so we will see it in action soon. There's another tab for the broker status. So this is a subscription to all these $sys topics, which are supported more or less by 2 brokers by now. So it's a Mosquito broker, and if you need a kind of an enterprise broker with high availability and some other unique features, you should have a look to the HiveMQ broker. So the broker sends, I think in an interval of 5 or 10 seconds, all the status messages to all these $sys topics. And this is my Mosquito version. I'm running on my Synology and the uptime and so on. So some status message. And there's also a log tab, which just displays what's going on inside MQTT-FX. Which messages were sent, which messages were received. Is there some errors or some exceptions inside the code of the tool? It will also be all be displayed here in the log. Okay, and the network I'm connected right now with my MQTT-FX client is this network at home. So at home I have some sensors inside and outside the house, and also some actors. There's a kind of remote switch to control the actors, because all of my actors by now are really cheap remote switches, controlled by 433 megahertz, so very simple and easy to use, because my remote switch here is just a Raspberry Pi using this really cheap, it's about €2 or something. This is a really cheap chip, which is able to send out the coding to this actor, so to this remote switch, telling him to switch on and switch off the connected device. The nice thing about this manufacturer here is that they don't, they not even have these kind of switches, but also this one, which can be placed inside an existing switch on your wall, so you don't have to break off your wall. Just if you want to remote control your normal already installed lights. That's really nice. So this remote switch is also an MQTT client, which receives MQTT messages telling him which device should be told to be switched on and switched off. It's a kind of message dispatcher to control all these actors. And I also have a bunch of sensors. And this is the MQTT topic structure. So I have a kind of domain name, Sweet Home. And this is a sensor, indoor, outdoor, and then the location, bathroom, living room, energy, backyard. And this is the, in fact, the value which is measured and transported by this topic. And this is the actor topic structure. So I have also an actor, indoor, outdoor, living room, front, backyard, and then most of the actors are controlling some lights, some LED lights, and there's also a controller for the fountain in the garden. So what I'm usually using at home is this little one. This is the ESP8266, and the sensors are connected via I2C bus to read all the values. And yeah, I mentioned it already. The 8266 has a full Wi-Fi stack and is also supported by the Adafruit MQTT library. So this chip is able to connect to the Wi-Fi and send MQTT messages or receive MQTT messages. Yeah, this is the hardware I'm using at home. So some temperature, pressure, humidity, UV index, luminosity, and so on.
The lights are can you control the luminosity or stuff like that, or just on off?
They also they also support this. Is it also called dimmer in English? I don't know. So the luminosity of the lights, it's possible. So I'm not using it right now, but I have this kind of module for being placed in a wall switch. It's possible, yeah. And then you will send, I don't know, values from 0 to 255, just to control the hue of light. Yeah.
So you can use it with any light, right?
Yeah, you can do that. Yeah. Yeah, or even you are creating with an Arduino and a pulse module modification, some analog values to control transistors or MOSFETs, to control RGB values of your LEDs, for instance. I've created also some clients. So if you're just receiving the values, great, fine, good demo. But Probably you want to use also or want to easily control all your stuff at home or somewhere else. And how is it called? The woman acceptance factor is very, very high if you're providing such a kind of app for all your mobile devices at home for easy usage of all this stuff. And this is really this client is installed on all our devices. It's written in JavaFX, and it's cross-compiled for iOS and Android. It's really this is native. It's not Java on mobile. It's a native client. It's a native app, which is now connected to my network at home. And it's basically an MQTT client. And as it's a Java application, it could also be started on the desktop. So it's with the Gluon plugin, you can create desktop applications and mobile applications on the same code base. So there's no change. I also made it some kind of responsive. See that? So it's the fonts are getting bigger if I'm resizing the window. So that's why it also fits on an iPad, and it's also used on a tablet. You can also use it on a tablet. And I think you've seen that the values are instantly updated. So it's all the same. There's also a kind of a log, which enables me and gives me an idea what the client is just right now receiving, and if it's connected and everything. So there are some on and off switches. There's some temperature values and pressure, humidity. I've also connected some currency sensors at home, so I'm able to summarize what's the current power consumption of the house. And there's a new thing to do just this to control LED values of some LED stripes and okay.
How much does it cost to implement this RGB tweaking? Because lights from major manufacturers of those lights are pretty expensive.
At home I've made some progress into some experience with just a common RGB LED stripe. Each channel RGB is connected to a MOSFET, and there's an Arduino. So it's an Arduino for 15, 20 euros. Some MOSFETs for 5 euros. Some resistors, what you will need, and the LED stripe basically. It's not that much. And then you have to think about an Wi-Fi shield or an Ethernet shield for the Arduino to enable it to receive messages from your local network, of course. But after that, you are able to control your RGB values just by sending MQTT messages. And there might be any client. It might the publisher of these messages might be a client like this, or some other stuff installed on your Raspberry Pi with a touch display or something like that. Or automatic, yeah. So I prepared a little demo. It's about the UV index. I don't know if you've heard about this UV index. It's kind of index of the intensity of the UV radiation outside of the visible light. So if it's green, UV index 0 to 3, everything is fine. You don't need any sunscreen, and then it gets worse, depending on the color.
Then you die.
Then you maybe violet is really extreme, so might be very comfortable and warm for quite a period of time, but then don't know.
It gets very cold.
Yeah. And what this is a demo setup which I'm using right now or soon. So I'm using MQTT as a publisher, and I have some subscribers. It's this control here. This is the UV index control, which is displaying the current UV index I will send soon. So I prepared my MQTT-FX client with some so-called predefined messages. For instance, you are able to define a topic you would like to send a message to, then a message, and then right-click on the text field, telling MQTT-FX it should place this message to the predefined message board, so clipboard message, name it, and the name of this message will be displayed on the button here, and will be stored as a predefined message. So once I press this button, I will send -1 to this topic, or 2 to this topic, or 5. So if I press low, see there's it's getting green, so I'm sending 2 to this topic. It's between 0 and 3, so it's green value. All clients who are connected right now will receive this message. So also this one. What you didn't see, I connected, and I instantly received the last message, because these messages are all sent with a retained flag. So I'm connecting the client and receiving the last received value. I don't have to wait for the next update interval to receive the latest messages. That's pretty nice. Just to mention, these clients are running on any iOS devices. So I have iPhone 5, iPhone 6. This is an iPhone 7, iOS 10. It's really running. I just compiled it and dropped it, the EPA file on iTunes, and synced it with a device. Or you're just also able to connect the device and transfer the client through your IDE. So it really works. And I have another client. It's this one. It's in there some NeoPixel rings and a 8266 ESP8266. I had this in my hand luggage today, and at Nuremberg Airport they controlled my hand luggage and were very curious what this is. So last week I was in San Francisco at Java 1, and not even the US border control complains about this, but in Nuremberg they said, "Whoa, what's that?" But yeah, I made it to convince them that it's not that dangerous. So this one should connect in a few seconds to the wireless LAN here, to the Wi-Fi. And hopefully, because if it's retained, it will receive the last known message and will show the current value. So this is green. This is moderate. So yellow, high, very high, and extreme. You see all the clients are informed about the current value because they are all subscribers, and any subscriber will receive the message. This is the script I mentioned earlier, and we had a look on. So this script just increases and decreases these values. So if I'm executing, all clients will receive all the messages. Where's the see? Also. Okay. That's for the demo, and it's all we've seen right now is all instantly. So all clients are MQTT clients connected to the broker and will instantly receive all messages which are published from all the sensors, but it's not stored anywhere. It's also very interesting to create a kind of time series database to have some historical information about the last night, temperatures, or values like humidity in your living room. Therefore, I successfully installed Kibana and Elasticsearch on Raspberry Pis. It runs very well. The Elasticsearch database, it's not really a database. I think it's more or less a data storage. Works very well on the Raspberry Pi, but Kibana is very much memory consuming, and the Kibana Pi often breaks, so I have to find another way to install it on a more reliable hardware. But what I'm doing here is also receiving all the MQTT messages. I have a kind of I called it MQTT Elastic Ingest component. It receives MQTT messages and creates JSON REST messages for the Elasticsearch database. The values are stored there, and it's just a breeze for Kibana to receive to grab all these values from an Elasticsearch database, and it's very easy to create these kind of dashboards and time series visualization then in your browser. Yes, I think so. Yeah. Well, at the end of the day, it is already available on the clients, not at the JavaFX client, but on the via the browsers of the tablet or something. Just as an outlook, what you can also do with all this MQTT stuff. This is a fast data pipeline architecture based on the SMAC stack. SMAC is for Spark, Mesos, Akka, Cassandra, and Kafka. And all these SMAC stack stuff is a toolbox which you can use for creating this kind of fast data pipeline. And also the MQTT protocol is used for transporting and creating the data stream, which is then produced by this kind of setup. But you can fill some additional talks with talking about this pipeline architecture, I think. So that's it so far with MQTT for the Internet of Things. These are my Bitbucket and GitHub repos. So if you want to, just go there and have a look at the source code. I have a blog which is placed under jensd.de. It's in English. It's DE is it's not the.
There's a blog talking about
Yeah, the blog is about MQTT-FX, of course, because it's a tool I'm working on since 3 years, about 3 years. MQTT-FX is free available. Just download it from mqttfx.org. There are bundled installers, so you don't have to install a system-wide JRE. It's bundled, so you just have to install the client for Windows, Linux, and Mac. Yeah. Yeah. So this you just in your IDE and as a Gradle target, you just have to tell it create an Android package, and then it's there. It's also compatible with the Play Store or the Apple App Store. So even Apple will accept your code to be placed in the App Store. Okay, questions? Yeah, there's a library. It's one library is called Pylite.org. They have CLI clients, which you can tell which hardware you would like to target, and they have all these reverse engineered encoding on board. It's all there.
Is the repository the same or have different?
They have different code. So some projects are in Bitbucket, the more new public projects are in GitHub, because mainly it's because of CodeCentric is a GitHub partner right now. Yeah. No. With displaying the values, it depends. So these controls here are displaying all values from 0. No. So this control displays all values from 0 to 11. And this one just controls the major color. Maybe that's why it looks like it was faster. I don't know. Okay, then thank you for your attention.